name is Malin, and today I'm going to talk about multi-platform development and Swiftui. But you know what? Let's do this a bit differently. Let's go for a walk. Let's head down to the seawall. Alright, there we go. So I'm originally from Stockholm, Sweden, and I lived in Sydney before this, and now I'm in Vancouver. And although I can't go around and show you all of those places, I figured it could be fun to show you where I am right now. So, this is Vancouver. And that's a pirate ship for some reason. But yeah, Vancouver. I love it when new frameworks, tools, and languages come out. I started working with Swift the night it came out, and I also done server-side Swift with Vapor for a while. And naturally, I was really excited when Swiftui came out. But let's keep on walking. That's Science World, by the way. Alright, so when Swiftui first came out, I was tinkering around with it, and I really enjoyed it. It was really cool how you could quickly put things together. But it wasn't until I needed an app to track my time and invoice clients that I decided to pretty much go full in. So my partner and I, we wanted a Mac app. We didn't know AppKit, so we figured let's just go ahead and stress test Swiftui because we've been told that it's going to work on all platforms. So let's start out with that. And we did, and we ended up releasing our Mac app, learned some AppKit on the way, and after that we went ahead to our iOS app and then later on to our watchOS app. And I think now is probably the good time to start heading back so I can show you the app and then continue with the rest of my talk and talk about Swiftui. Hi Kai!
Welcome back.
Thank you. Okay, so let me show you what the app looks like. So this is Orbit, this is the Mac version. And in general, we try to provide features that are specific for the platforms. So if you click something in Orbit on the Mac, it tends to open up in a separate window. So we really use that multi-window support. Shortly after we released our Mac app, we also wanted an iOS app. So we decided to continue along with Swiftui. So we released our iPad app and our iPhone app, or our iPadOS app and our iOS app. And we kept that same approach. So on the iPad we have a sidebar navigation flow, or you can navigate through the apps through the sidebar, whereas on the iPhone we have a tab bar in the bottom. And that's just, again, we wanted to have that platform-specific experience. And shortly, quite recently actually, my partner and I thought, why don't we make a watch app? Because we often go out and take walks and we often talk about projects we're working on. So we wanted an easy way, it's too annoying to pick up the phone all the time. So we wanted an easy way to start and stop a timer. So we built an Apple Watch app as well. So my talk today is about Swiftui and how we can use it for multi-platform development. And this ended up becoming more of a relevant topic than I had anticipated, because 1Password announced that they will be using Electron moving forward for building their Mac app. And I think that got a lot of people just reflect over the current landscape for macOS development and the different tools that we have there. Because we do have Electron, but then we also have Swiftui and Catalyst and AppKit, and there's just those 4 different ways. There are different ways of doing it, and I think it does depend on your use case and what you're building, but I think for us it was a lot about, we primarily wanted to make a great Mac app. We want to make something that was platform native and that really used all of the functionality of the platform. So realistically we only had 2 options. So we had AppKit and Swiftui. And we started making our app in beginning of 2020, and it just felt odd to go with AppKit at that point, because SwiftUI seemed like a tool that we'll be able to continue using for a long time, and it seemed sort of like the new thing that we could use. And that's why we decided to go with SwiftUI, and we knew that worst case scenario, we bridge over to AppKit and we can use that there. We can use AppKit as well. But we really tried to push it in the beginning, and we really focused on using SwiftUI for everything. And I was personally frustrated when it felt like things didn't work as I expected for the Mac, or things weren't available. And that was partly frustrating because I wasn't aware of what was available and what wasn't available. So it took some time to sort of figure out what you can do with SwiftUI and what is not possible yet with SwiftUI. But once I got sort of used to that, and once I stuck with SwiftUI for a long time and found out what wasn't possible, I became more sort of acceptant of using something like AppKit instead, or bridging over to AppKit. And I think there's a good reason why Apple has provided good tooling for us to use SwiftUI together with other frameworks like UIKit and AppKit. And that is because everything is not going to be available for SwiftUI yet. I think a lot of things will continuously become available, and Apple is definitely building more and more things directly in SwiftUI. But once I started understanding what is possible and isn't possible, that made me just a lot more comfortable using SwiftUI. And I used it as one of the tools for building apps, but I use it in combination with AppKit and UIKit. And I think that's fine. And yeah, I think a lot more things will become available. But now when I build an app, I don't expect to only use SwiftUI for it. And I think that's okay. SwiftUI has a lot of parts that it does really well. And if I can get benefits from those, and with Orbit, the majority of code base is written with SwiftUI. But if I have to put some AppKit or UIKit in there, that's okay as well. Another point that I thought was a bit frustrating in the beginning, and still is frustrating, is that there are bugs in SwiftUI. And in the beginning, I felt like my partner and I were the first people running into it, because it is a new framework. But we have seen that as we continue filing radars or filing feedbacks, things are being addressed and things are being fixed, and more people online are starting to use SwiftUI, so you will be able to find more and more answers as well. But yeah, bugs are annoying. It's something that you get in other frameworks as well. I think SwiftUI hasn't been through as many iterations as other frameworks, so there might be more of them there. And yeah, that of course is something that is still frustrating for me today. But I'd say that after using it for a while and knowing about those bugs, I also have my own sort of toolkit on how to deal with them, and I'm aware of what to watch out for when it comes to those bugs that I will potentially run into. Alright, so even if I use SwiftUI with AppKit and UIKit today, I can imagine SwiftUI becoming more of a primary tool that we use on different platforms, but also across the different platforms. And that is something that we already see becoming more of a thing. So we've seen Apple releasing more and more features for SwiftUI directly, but there are also platform-specific features in SwiftUI. So we're getting functionality added to SwiftUI that's only there for the Mac or only there for the iPhone and the iPad. So I think it is really starting to tailor itself to be a tool that we can use to make great native apps on those different platforms. But there are also some other things that sort of indicates to me that the platforms are being brought closer together. So we're getting more and more frameworks and more functionality across the Mac, iPad, iPhone, and we have things like shortcuts, we have things like focus mode or widgets, the share play functionality. All of those things are not only on one platform, it's something that is available everywhere. So it would make sense that you would want to have apps that can utilize all of those different frameworks and all of those different functionalities across the platforms. And those features that are available on multiple platforms still take sort of different shape on the different platforms. So if we look at something like widget, it is something that stays on your home screen. It looked quite similar to what it looks like on the Mac, but the behavior is different and it's sort of been adopted. So on the Mac, you want to be able to access it quickly by swiping in from the right of your screen, whilst you wouldn't want them on your home screen necessarily because you don't look very often on your desktop. So it's great to see that those features are still being specifically adopted for the platform that they are being built on. But this is where I think Swiftui naturally fits in, because we want to build apps that uses all of those features. So I do think Swiftui is sort of part of that approach of bringing development for the platforms and bringing the different platforms closer together. So I found this to be really interesting, because even if you want to get started learning Swiftui for one platform, let's say you want to make a new iOS app or you want to add a feature to your existing code base, that's a perfect place to get started, and that's a great way of getting used to Swiftui and learning the framework. But once you know it, that will have lowered the barrier to enter a new platform. So if you later on want to make a watchOS app or a macOS app, you can do that because you already have one tool to get started with. So when it comes to multi-platform development and Swiftui, I think it's important to think of it as something else than a cross-platform tool. It's not about writing our code base once and then have that run everywhere and magically look great on the different platforms we want to support. It is about learning a framework once and then using that framework everywhere. So if we want to make an iOS app, a Mac app, an iPad app, or a watch app, we should still expect to build for those platforms. And I think that's an important distinction, that it is a tool, it is a framework that we can use, and it's beneficial that we can use the same one across the platforms. But the platforms are still different platforms, so we need to build the features differently for that and build different apps for those platforms. So if you look at Apple's shortcuts, for example, I think this is a good scenario where they used Swiftui, but they are really accounting for the different platforms and they build something unique for the platform. So on iOS, it is an iOS app and it looks like you would expect an iOS app to look like. And on the Mac, it uses the behaviors that you would expect on a Mac. So if you create a new shortcut by clicking the plus button, that opens up a new window. So they have really adapted it and provided a good experience on the different platforms that the app is running on. And yeah, some of the code base in this app and in Orbit are probably shared, and that's something I really like when I use Swiftui. If I build a feature, I don't have to build the entire feature from scratch if I want to have an iOS version of it and a macOS version of it. But the UI itself will have to be adapted and will most likely look quite different on the different platforms. There are some situations when you can reuse some of the UI, but I don't think that should be the key reason why you're using Swiftui. I think it's important to see all the other benefits of Swiftui and then have the potential of being able to reuse some of the components and some of the UI. Having these type of components is something that Swiftui already encourages us to do. And it's something that is very helpful when you want to reuse certain part of your app, both within the app itself and potentially also across different platforms. But I don't think you should expect everything to be reused across those different platforms. I'd like to think of it like spices. So actually, let me just show you. Okay, so let's say we want to make a meal. I got a really good butter chicken recipe, so let's go ahead and make that. I mean, we're not going to make the entire meal because this is not a cooking show or a conference about cooking. We'll get back to our slides quite soon. But let's finish this analogy. For our butter chicken, we're going to need ginger, and we're going to need cumin, cardamom, coriander, cinnamon powder, and chili powder. And then we'll combine all of those spices to make butter chicken. Once we're done with that, we will put this away. Ideally in a pantry, but we don't have time to do that for this. So let's just push them aside. The next day, we might want to make a different meal. So let's say we want to make chili. So for chili, we're going to need a different set of spices. So for that, we'll need paprika powder, garlic powder, and onion powder. And we'll also need chili powder and cumin. And those are spices that we bought for our butter chicken, and it wasn't intended for a chili, but there's no reason why we wouldn't just go ahead and use those. So we're gonna go ahead and get our chili from the butter chicken and get our cumin, if I can find it. So we get our cumin. No, sorry, that's coriander. We don't want to put that in chili. So we get our cumin. So now we have those two spices that we can use in our chili as well. And that is sort of how I like to see Swiftui views and Swiftui components. We might build components for one platform, but then when we decide that we want to build for a different platform, we can use some of the components that we already have from the previous app. Does that make sense? Yeah, I'm sure you get it. Okay, so let's have a look at how we can get started using Swiftui and some more practical use cases. So for those of you who are not familiar yet with creating a project for Swiftui or a Swiftui project, when you Xcode provides you with this option to have a multi-platform project. So if you select that, Xcode will provide you with a abstract. So this is the entry point to our app. From here, we hand over to our content view. And the content view is that initial UI that we'll see. In this example that I have here, it is just a app navigation view. So that is just the entry point or a navigation view for the user. And then that view presents different views in itself. And in general, you will notice with Swiftui that everything is split up into those different views, and those views have their own leaf components. Another part that we get for Swiftui when we create our project is this project structure. At least we usually get this project structure. I did not get this project structure when I created it with the beta version of Xcode. So I'm not sure if it's going away or if it was just not there temporarily in this build. But I usually like to split my projects up into those type of folders. So I have a shared folder with the components that I'm going to use across the different platforms. Then I have an iOS folder and a macOS folder, and you might have a WatchOS folder as well if you want to have a watch app. And after that, I know this might sound a bit counterintuitive, I like to focus on one platform. And there are a few different reasons for this. I think it's helpful when you learn a new framework to focus on the one platform first, and there are some differences between the different platforms. So rather get comfortable with the tool on one platform and then use that on the other platform afterwards and adopt and learn the new things that are specific for that platform once you get to that. Another thing that I found beneficial is that focusing on building for one platform really helped us flesh out all of the functionality and the behavior we wanted in the app. And then we could reuse a lot of that and apply our own different UI structures and our different design for the different platforms. But we had our foundation there, so that was really helpful as well. Another thing for me was that picking Swiftui up on a new platform like macOS really enforced me to stick with it. And I'm not sure if this is something I recommend because it was also a bit frustrating. But when I worked with Swiftui on macOS, I couldn't just move over and bridge over to... I was less encouraged to bridge over to AppKit because I didn't know that already, because that felt for me like I had to learn an additional thing. So I really thought, okay, maybe this is possible in Swiftui. And then I kept on researching it and I tried to debug things and I tried to really learn Swiftui as a tool first, and then later on recognizing what wasn't available, and then move over to AppKit. So, which platform do we choose? For us, it was pretty clear. Like, we just wanted a Mac app. That was the primary goal for us starting to build this. And it wasn't more of a decision than that. And if that is your situation, if you have a specific app in mind that you want to make, I think that's great. I think it's perfect to start with the platform that you're the most excited about. And if there's a particular app that you want on your Mac or that you want on iOS, then that is a great incentive, because if you do run into some hurdles along the way when you're starting to learn Swiftui, it will be a lot more, you will be more motivated to continue sticking with it if you do have a particular app for a particular platform in mind that you want to make. Okay, so once we decided what platform to start with, for this example, let's go with macOS, we can start thinking about how we want to structure our UI. So, as I mentioned earlier with the spices, this is where I think it's important to consider the different components of our app and think of our UI in terms of those components. Because that's really going to help us both in, like, not just if we want to move to a different platform. And as I mentioned before, I don't think that should be the core goal here, but it will help us a lot through the development process for a single platform as well. So it just makes, if you split things up into components, you avoid something that could be similar to a massive view controller problem that you would have in UIKit. So if you do split things up into components, you get those pieces of code that are a lot easier to handle. So let's go through some examples. This is the Orbit dashboard that I showed you earlier. And if we look at this, it has all those different tiles. But each of these tiles are split up into their own components. So for example, the total time dashboard here is a component in itself, but we also have the title being a component, and then each of the bars are their own components. And that was just a way for us to be able to easily handle this one piece of the code. Another example of a component that we have is this list of different projects that you've been working on. And then each of these rows in themselves are their own components. So this is an example where it's useful to split things up into components for the sake of us managing the code better. A scenario where the sort of reusability on a single platform comes in as a benefit from splitting things into components is this amount earned section that we have. So this is a section that we display both in the day view and the week view, but it looks pretty different, or it's laid out in a different place and in a different card on the different tabs. And this is a scenario where we split it up into a component, and then we could use it and sort of put it into the places we wanted depending on what the layout was. So then the parent itself is constructing those different views depending on what we want the views to look like for the day and the week view. Alright, I know that there's a lot more to it when we talk about building a Swiftui app for a single platform, but I think the things that I mostly want to highlight was how to think about those components and how to think about how I think about the structure of the view of the UI code. So now we already have a good starting point when we want to move over to the next platform. One benefit that I mentioned earlier is that we have a framework and we can just directly go over and start building for a new platform using the same framework. But another benefit that we have is that we have already built all of our underlying structure and all of our underlying logic that we want for one platform. So all of the features are in theory done, but we want to now move over to making the UI look and feel right on those platforms and build specific UI components for the platform we want to adapt. One benefit that we saw with Orbit, which I really didn't expect, was coming from us. So what we decided to do when we wanted to move from macOS to iOS was to, just for fun, build the project and see what it looks like on iOS. And it didn't look good. It was not at all laid out the way we wanted to, and we didn't expect that either. But we did this because we wanted to first experiment, see like, oh, how does this look like? And that was fun. But the other thing was that we wanted to make sure that everything runs. And we wanted to test the core flows that we had. So we wanted to test the authentication flow to get into the app, because that is a key component of using an app. You have to be able to authenticate. And we were able to do that. And from there, we weren't actually sure what we wanted our login flow to look like for iOS, but we did know what we wanted the other UI parts to look like. So we actually ended up sticking around or keeping on using our macOS login flow for quite some time throughout the development process, because it really helped us for the rest of the development. And we knew we would never ship that, but it meant that we could log into the app, we could iterate on the rest of the UI, and then return to the authentication flow later, which we ended up doing, and then we built a specific UI component and the specific UI for the new platform. That's just a fun additional benefit that we got, which we really didn't expect, but it did really help throughout the development. So once it came to us actually building our iOS app, our focus was a lot on the UI itself, because as I mentioned, we had all of the underlying logic there already. But there are also some other things that we had to consider when we adapted our UI and when we started building specific feature or specific UI pieces for the new platform. And this sort of goes back into the structure of our code itself, because if we want to start supporting a new platform, we also have to adapt and structure our code in a slightly different way so that we can build for the different platforms, and so that we have different UIs that we provide to the different platforms. Because in the end, we do have one shared code base, and we still need to determine what to display when and what to show on each platform. So there are a few different ways that we do that in Orbit. There's a few different techniques that we're using when determining what we want the app to look like on iOS versus macOS. So for example, on a high level, when you first enter the app, like the entry point of the app almost is the navigational flow. So this is where we started looking both in terms of what we wanted the app to look like, but also in terms of how we want to structure our code base. So on iOS, we have a tab bar in the bottom, and that handles all of the navigation. That handles which UI we want to display and which screen we want to display. And this is just a behavior that a user expects. A navigation bar in the bottom is very standard on iOS. While on macOS, we have the sidebar that I showed you before. And that is, again, a very native behavior, and we wanted to use that. And a sidebar is something that we also often see on iPads, and that's something we wanted to adapt there as well. So we want to make sure that on iOS, macOS, and iPadOS, we do have the different navigational hierarchies that you would expect on that platform. So what this looks like when it comes to the code is that we have a content view, which is the same content view for all the platforms. So this is what's being presented from our abstract. And this content view itself decides what we want to display, depending on the platform that we're running on. So if we're running on macOS, we are displaying a sidebar navigation view, whilst on iOS, we're displaying a tab navigation view. And we do so by checking which platform we're running on here. And then when we wanted to have when we want to have that sidebar on both macOS and on iPadOS, we decided to add this horizontal size class check. So in Swiftui, you can get this environment variable, which is a horizontal size class, and you can use that to determine what UI you want to display or what behavior you want to provide. And if the app is in compact mode, so that is either running on an iPhone or in a split screen on the iPad on the smaller size, then we are displaying a tab navigation view. Whilst if we are running on a wider screen, so like a full screen iPad, then we would display the sidebar navigation view. And this is the same sidebar navigation view that we already used on macOS. So this is a scenario where we split up our code and the UI on a very high level, in a very early state. Already when we present in the content view, we have different flows and we have different pieces for iOS, macOS, and iPadOS. And I feel like that is a natural point to split our UI, and I think that will be quite common that people might split the UI at an early state because those navigational flow on the platforms are so different. So this is just a natural point where we can hand it over and have different code for the different platforms, and then some pieces and some components down the line and some of those leaves might be reused across the platform. Another thing that we use quite often in Orbit to display different UIs on the different platforms are compiler directives. So that's something you probably saw earlier in my code. These are the checks that we are using to check, are we running on macOS or are we running on iOS? And depending on which one we're running on, we're displaying different UIs. And in general, I found this to be useful, both if we want to display separate files on that higher level, so we want to display a tab bar versus a sidebar, but it's also quite useful for smaller things. So if we want to make some modifications onto our UI, but the UI in general might be very similar, we can use compile directives. And as of Xcode 13 and this year, we can apply our compile directives directly around our postfix expressions. So in the past, we would have had to apply these if-else clauses around the entire SwiftUI element. So, for example, we would have to apply it around this text element and then have different modifiers depending on what platform we're running on. Whereas now we can use them directly around our postfix expressions. So we can have a check if we are running on iOS, and then we might apply a different font than what we would do if we're running on macOS. So another place where I found compile directive to come in really useful is if we have different behaviors that we want to account for on different platforms, or different interactions rather. So for example, in Orbit, we have a dashboard with a graph in it. And in that graph, you can select different bars. And if you select them, we want to highlight them and change the opacity of them so that we indicate which graph bar is selected. And we want the behavior for this to be different on iOS and macOS. So on iOS, we would want to recognize a tap gesture. So we use a compile directive around that to check if we're running on iOS. And if so, we apply a tap gesture. Whilst on macOS, users would expect this behavior to happen when you're hovering over something. So if you're hovering over a bar, then we want to highlight which bar is being hovered over. So we use it again to apply a different modification for macOS. So compile directives are great, but it can become a bit messy in your code, especially if you want to apply the same type of modification multiple times throughout your app, and you know that you always want something to look different on iOS versus macOS. So let's go back to our simpler example with the text label. Let's say that we know that we always want to have different UIs or different styling applied to our text depending on what platform we're running on. Then we can create our own view modifier. So we can apply it directly on the text label itself, and there we can abstract some of that logic of what we want to display on iOS versus what we want it to look like on macOS. So in this example, we have a text with backgrounds. So let's say we have a few more things we want to apply to our text. It's not just a title change. We also want to have a different color on the background or some different styling there. We can create our own view modifier here. And what this is that it's an extension on text in this scenario. If you do want to apply a difference for views as well, or a different modification on a view, you can have an extension on a view. But in this scenario, we always want to apply it to text. So we're adding an extension on text, and then we have our function called text with background. And what this does is that it checks if we're running on iOS or if we're running on macOS. And if we're running on iOS, we apply our modifier, which is our text with background modifier. Whilst on macOS, we have a different modifier that we're applying. And just to show you what that looks like, this is our text with background example. And macOS would look different because we would want it to look slightly different on that platform. But this is our custom view modifier, which is taking the content that we want to display. So it will be the text that we want to display. And then it applies the styling that we're after for the text. And the benefit with this is that it can be used across the app without us having to add a lot of, so with this example, we have a lot of modifiers that we want to apply. And let's say that we want to do that on a lot of different text elements. It's nice to just have this in one function and in one view modifier that you can use directly. Okay, so these are a few of the techniques that we're using for applying different styling and for structuring our UI code for the different platforms in Orbit. And I know these are different techniques, and it might be hard to decide when to choose which of those techniques. And in general, I found that starting at that higher level and looking at the navigational flow and see the behavior of the app and look at how the apps are going to behave different on the different platforms can be a really good starting point. Because then you know what bigger pieces you want to have separate. So you know if you want to have a separate flow for the different ones, so separate navigational flows. And if a view looks completely different, so for example in Orbit, our time entry view looks different on macOS versus iOS and iPadOS. And if you know that you want to do that, then it might make sense to separate that out into a separate file. But if there are just some smaller changes and the view itself is very similar on the different platforms, then I think something like compile directives or view modifiers can be really helpful techniques for that. So one place where I found smaller modifications like view modifiers or compile directives are really useful is when we are reusing those UI components. So I mentioned earlier that if we split things up into components, that is beneficial for a single platform. But this is where we might actually benefit, in some places we might actually benefit from this when we move into a new platform. And I mentioned earlier that this should not be the expectation, but it can be an additional benefit of Swiftui. So if you have certain components of your app that are specifically designed for your app that are not going to be different on the different platforms, that might be a perfect component to reuse. So for example, let's get back to the dashboard in Orbit. This graph is something that is our own sort of custom component. It looks in a specific way that we want it to look like for Orbit in general, but we don't have that many. It looks very similar both on macOS and on iOS. So the fact that we split this up in a component already to make it easier to work with on one platform can be beneficial now when we move to iOS. So we were able to reuse this one on iOS, but we present it in a very different layout. So here we have it in a vertical scroll view versus that grid view that we have on macOS. Another example of those components was our day view, and I showed you this earlier, but I didn't highlight it. So we have this graph or this bar which shows you how much you've been working, how much time you've been spending on each project on a day. And this is something that we know we wanted to look the same on macOS and on iOS, so we could reuse this particular bar across both of the platforms. But the place that it's being laid out and all of the components around them are very different. So on iOS, this bar in itself is being reused, but the bottom section of the card and of this graph display is different on iOS versus on macOS. And then if you do have some differences with those components, like I mentioned with the bar graph, it's the same component, but we want the behavior to be different. So we want to be able to tap it on iOS versus hovering on macOS. Then that's a great use case for a view modifier or a compiler directive. So I've been talking a lot about Swiftui now and how we can structure the code only in Swiftui. But as I mentioned, Swiftui doesn't have everything yet. So sometimes we might need to get some help from some friends. So we might want to add some UIKit and AppKit into our app. Apple already provides protocols for this. So we have a UI view representable when we want to add a UI view into our code, and a UI view controller representable if we want to add a UI view controller. And then we have equivalent on AppKit as well. So an NS view controller representable and an NS view representable. I'm going to show you the iOS examples here. So in general, these protocols are ways for us to integrate or to use UIKit components and AppKit components in our Swiftui codebase. So for example, in Orbit we have this screen where we want to have a page controller and a page view controller at the top of the screen. So this was a place where we needed to use UIKit for this. So if we look at this component, we have two different parts in it. We have our page controller and then we have our page view controller. So this is where we are using a UI view representable and a UI view controller representable. And in general, UI view controller representable and UI view representable have similar structures. So they both have this function, which is a make UI view function. And what that does is that it creates our UIKit component. And in our scenario with the page controller, we would create a UI page controller there and return it. And then the next function is our update UI view. And that is where we do any type of updates to our UIKit component that is coming from Swiftui. So this is a way for Swiftui to communicate with UIKit any changes that should be reflected in that UIKit component. So make UI view and update UI view are some of the more common functions that we'll be using when we are creating a UI view representable. In scenarios where we also want to communicate changes from UIKit to Swiftui, we can use a coordinator. So if we look at the page view that I showed you earlier, we might want to inform Swiftui of which page currently is selected. So we might want to have a target action here that communicates what the current page is to Swiftui. And that's when we can use a coordinator to inform Swiftui of the current page. So we would add a coordinator in a function that is called make coordinator. So what this does is that it creates our own coordinator that we want to handle this target action. And the return coordinator is a NS object that we're creating within our UI view representable struct. So a coordinator can also be used in a UI view controller representable. So if we go back to this example with the page view controller, we could have a coordinator that conforms to UI page view controller data source and UI page view controller delegate and handles all of our data source and delegate methods. So in that way we can communicate changes in our page view controller to Swiftui. So for example, we might want to let Swiftui know when we have completed a transition in transition completed, for example. Okay, so we have our UI view representable and our UI view controller representable to add a UI view and a UI view controller into our Swiftui codebase. But let's say we also want to be able to add an app delegate, which is another part of UIKit. Then Apple has provided us with a UI application delegate adapter. So if we do want an app delegate in our Swiftui codebase, for example, for building shortcuts or support for shortcuts, then we would use a UI application delegate adapter on iOS and a NS application delegate adapter on macOS. And this allows us to use our standard UIKit or AppKit delegate directly in our Swiftui code. Alright, the last thing I just want to mention is if you are interested in picking up Swiftui, but you already have a UIKit app and you already have an existing code base, then you might want to start adding a specific component or a specific part of your app you want to add in Swiftui or you want to make in Swiftui. Then there is the host controller, our UI host controller. So this UI host controller is a component that we can use directly in UIKit, and we provide it with a root view. And this view itself, that's our Swiftui view. So this is a way for us to integrate it, and then we can use this UI host controller directly in our UIKit or AppKit codebase. So now when I used Swiftui for making a Mac app and for making an iOS app, I feel really comfortable with the framework and I really enjoy using it. One thing I would keep in mind when creating a new project is the versioning that I want to support. So there are still there are a lot of things that have been added to Swiftui since it was released, and I think a lot of things will continue being added to it. So if you are able to only support the latest version of the OS that you're running on or that you're building for, I think that saves a lot of pain points along the way, and it also allows you to use a lot of the very nice parts of Swiftui that have come out more recently. So that's something I would do if I create a new project. I'd use Swiftui, I'd support the latest version of iOS or macOS, and then bridge over to AppKit or UIKit if I would need that. Alright, thank you so much for listening. If you have any questions throughout the conference, feel free to send me a message on Slack. You can also get in touch with me on Twitter. So thank you and enjoy the rest of 360 Item.